Question number 4. Some ceiling lights in the homes are connected to the main by two core cables only. Figure number 6 shows a ceiling light. If you look into the ceiling light, the copper wires have the insulation and there is a insulation on the whole wire also. Suggest why some ceiling lights do not have the earth wire. This question is an AO3 question and this question is from main electricity topic. When the thick insulation is present, the earth wire is not required usually. Let's see our model answer. The ceiling light is not made up of metal. Therefore, there is no chance of electric shock. So no current is flowing in the casing of the light, and if a person touch it, there is no chance the person will get the electric shock. Therefore, earth wire is not required for the ceiling light. Four point two is an AO1 question. Write down the equation that links charge, current, and the time. This question is from electric charge and the current. The student need to write the formula which can relate the charge flow, current, and the time. The student must remember the formula. The formula is charge is represented by capital Q and the current is represented by capital I and the time is represented by small t. Four point three is an AO2 question from the same topic. The current flow is 2.95 ampere in one of the copper wire for 60 seconds. Calculate the charge flow. The student needs to use the equation used in 4.2. In our question, let's see what is given. The current is given 2.95 ampere, time is given 60 seconds, and student need to find the charge flow. The equation is given here. We will use the same equation. The charge flow is equal to the current times time. We will use the given values. The current will go here and the time is used here in the formula. The charge flow, that is equal to 2.95 times 60. That is equal to 177 coulomb. Four point four is an AO1 question. Figure number 7 shows a current potential difference graph of a piece of copper wire. This question is from the topic of resistors. Draw another line on the figure number 7 of a wire with a different resistance. So it is a wire, so definitely it is a straight graph passing through the origin. That straight line the student can use, it can be above or it can be below of the given line in the figure number 7. If the resistance is less, the more current will flow. If resistance is high, less current will flow. So the graph will look like this one. I chose a graph in which there is less resistance, therefore more current will flow through the wire. If the wire has a high resistance, then the line is below the black line, starting from the origin. Students have to ensure that the lines are drawn with the help of the ruler and passing through the origin. For low resistance and for the high resistance. 4.5 is an A1 question. Some fuses have a thin piece of copper that melts if the current is too large. This question is from the circuit diagrams and the symbol. Draw the circuit symbol for a fuse. To draw the symbol of a fuse, we need to draw a straight line passing through this rectangular block. 4.6 is an AO1 question. Describe how the movement of the copper particles in the wire changes when the copper melts. This is an AO1 question, and this question is from density of material. In solid form, the particles are very close to each other in regular arrangement or in the fixed arrangement, but on heating, the copper wire will melt, the density is reducing, and the particles start moving away from each other. So the particles are arranged in the regular arrangement in solid copper, and the particles are vibrating at their fixed position. But on melting, the particles will get free and they start moving in the molten copper. Let's see the model answer. The particles are arranged in regular arrangement in the solid copper, and the particles are vibrating at their fixed position in the solid copper. But in molten form, the particles are free to move. 4.7 is an AO2 question, and this question is from specific latent heat. Old copper wires are melted when they are recycled. Calculate the energy needed to melt 500 kilograms of copper at its melting point. The specific latent heat of fusion of copper that is given 200 kilojoules per kilogram. Use the equation sheet to find the value of energy. In this question, we need to convert the unit first because the specific latent heat of fusion of the copper is 200 kilojoules per kilogram. We need to convert kilojoules into joules first. In given specific latent heat is 200 kilojoules per kilogram. Kilo means 1000, so 200 times by 1000, so we get the value 200,000 joules per kilogram. Whereas the mass of the copper is 500 kilogram. The student need to find the energy to melt the copper. From the equation sheet, we know that specific latent heat formula is E is equal to mass into specific latent heat value. We will use these values here. The mass is coming here, and the value of specific latent heat is used here. So energy that is equal to 500 times 200,000. By using the calculator, we have the answer 100 million. So energy used to melt 500 kilogram of copper is 100 million joules.